Have you ever wondered what lies beyond the edge of the known universe? What would happen if you fell into a black hole? Would you be crushed, stretched, or perhaps transported to another dimension? In today's video, we journey to one of the most mysterious and extreme places in the universe, the heart of a black hole. We'll explore the science behind event horizons, spaghettification, singularities, and the wildest theories about what lies beyond. Let's begin. At the edge of gravity's deepest pit. A black hole is a region in space where gravity is so strong, not even light can escape. It's created when a massive star dies in a supernova explosion and its core collapses under its own weight. This collapse squeezes all the mass into an incredibly small point, a singularity, where density becomes infinite and the known laws of physics break down. Surrounding the singularity is the event horizon, the boundary beyond which nothing can return. If you cross it, you're gone from the observable universe forever. But how do we know black holes exist if we can't see them? By watching what they do to nearby stars, gas, and light. When black holes devour matter, they heat it up into a glowing disk, emitting powerful X-rays and jets of energy. In 2019, the Event Horizon Telescope captured the first ever image of a black hole, a shadow surrounded by a ring of fire. Now imagine you're approaching a black hole. From a distance, it might look like a glowing whirlpool in space, surrounded by warped starlight. Time begins to stretch as gravity pulls harder. You're entering the realm of gravitational time dilation. To an observer far away, you seem to slow down. To you, everything else speeds up. As you get closer, light bends around you. Stars behind the black hole begin to appear in front of you. You're not just falling through space, you're falling through time itself. Just before the event horizon, you reach a point of no return. As you cross the event horizon, something incredible happens. Or rather, nothing does. At first. You don't feel a bump. No alarms go off. From your point of view, you're just continuing to fall. But to the outside world, you freeze in place, fading slowly to black. Now inside the event horizon, all paths, even those pointing outward, lead inward. There's no going back. Gravity grows stronger. Space gets tighter. You're being stretched head to toe, an effect scientists call spaghettification. Your body becomes a long, thin stream of atoms as tidal forces grow stronger the closer you get to the singularity. So what lies at the center of a black hole? The singularity, a point of infinite density and zero volume. Here, space and time cease to exist in any meaningful way. Our current physics, even Einstein's general relativity, can't fully describe this region. To go further, we need a theory of quantum gravity, something that unifies general relativity and quantum mechanics. Some scientists believe that singularities don't really exist, that quantum effects create a core instead. Others propose the singularity is hidden inside a black hole's structure, protected by cosmic censorship, a hypothesis that prevents naked singularities from forming. But what if the story doesn't end there? Some theories suggest that a black hole's core might connect to something else, a wormhole or a white hole. A wormhole is like a tunnel through space-time, a shortcut from one point in the universe to another. In theory, entering a black hole could lead you out, somewhere else. A white hole is the opposite of a black hole, a region where matter and light can exit, but nothing can enter. Could black holes be entrances and white holes the exits? So far, we have no evidence these exist. But in mathematics and science fiction, the door remains open. Falling into a black hole is a journey of no return, at least as far as we know. It challenges everything we understand about space, time, and reality itself. Black holes aren't just destructive. They may hold the secrets of the universe. They test the limits of physics, and perhaps even our imagination. So what happens beyond the event horizon? No one knows. Maybe it's the end, or maybe it's a new beginning.